All right, so welcome everybody to the Aerial Robotics Working Group for July 5th, which is going to be a scientific presentation. Is going to be presented here at this meeting. We're all going to listen to, and that's going to be given by Alejandro. I hope I spelled your name correctly. Yes. Yeah, consultant at Open Robotics, so that's also correct. About Vehicle Gateway, where it kind of connects a couple of these autopilots together, Autopilot and Betafligth, perhaps more in the future. So after that, we're going to have a Q&A discussion about that presentation as well. So you can just ask him all kinds of questions. And after that, we can do a topic selection for the next developer technical meeting, which is going to be on the 16th of August. So we're going to have 1 month of a break. So without further ado, I'm going to stop presenting and then you can present your slides. Go for it. Okay, oh wait, it says Alejandro is no longer, oh, there you go, perfect. It all works.
All right. Yeah, so thank you for introducing myself. So yeah, I'm Alejandro Hernández Cordero, so I'm a consultant robotics software engineer at Open Robotics. And I have been working in the past with Autopilot, so it's not my first touch with PX4 or Autopilot. So in the past, I worked in a company that we made, I don't know if it was the first, but I mean, the first Autopilot that worked in a microprocessor. So yeah, the company was called Aerial Robotics. So yeah, we were based in Autopilot, and it was a long time ago, probably 8-9 years ago. But I mean, I was always, let's say, close to the drone community somehow. All right. Oh, we can go here. So yeah, so this is the index that I'm gonna use today for the presentation. So I will introduce the Vehicle Gateway repository that contains a set of packages, of ROS packages. Then I will talk a little bit about simulation testing. I will show you how to configure multi-robots. Then I will show you the demo wall that we have prepared for all these demos. And finally, we're gonna talk a little bit about the Sino demo that we have and why we use Sino and not only ROS2, and some conclusions for the talk. So let's start with the Vehicle Gateway. So the Vehicle Gateway, the goal of this project is to create a plugin-based C++ library that can interface with several vehicle SDK. So in other words, we are gonna create some libraries that we can load in runtime, and we are able to, let's say, use an API that allow to, with the same API, allow to use different libraries as a backend, and we were able to, use the same API for different autopilots. So here the idea is one API to rule them all, and the idea here is that imagine that we want to run a vehicle. So in general, different autopilot doing different ways. So for example, Betafligth, that is one of the autopilots that we're going to talk today. You need to press a button or just, in the RC, press a button, move the throttle and so on. And some other autopilots, such as PX4, that has more, let's say, high-level APIs, allows to send a message with ROS2, and you can arm the vehicle. But at the end, both vehicles wants to arm. But I mean, we try to hide the complexity that are behind all these autopilots in this API. So which packages we can find here? So there is a package, or there is some packages to download and install the required targets to run software in the loop, because right now the main goal of this repo is to run simulations. But I mean, it's very easily, so you can very easily use this for real robots. And we have Betafligth and PX4. So with these packages, you were able to run the PX4 executable or the PX4 related tools such as Commander, Listener, whatever, when you source your ROS2 workspace, and the same thing with your Betafligth CTL executable. The same idea here for the ground stations. So in general, each one of the autopilots work better with different ground stations. So for example, PX4 work pretty well with ground control, but Betafligth has some specific things that you need to configure with the specific configurator. So for that goal is the Betafligth configuration. So again, you download the package, you compile the workspace, and you will be able, with the launch file, to load these ground stations very easily. And finally, there is this vehicle gateway, which is the repository is called vehicle gateway. Well, I mean, the main package here is the vehicle gateway. And again, it's a plugin-based system for interfaces to vehicle SDKs. And right now we have 2 implementations of this API. The first one is the Betafligth plugin for vehicle gateway. For those who are not familiar with Betafligth, this autopilot is, the aim of this autopilot is to use it for race drones and low control. The vehicle gateway PX4 is the implementation for the PX4 vehicle for the PX4. And here are the dependencies that are required for these packages. So the vehicle gateway is a very simple package. It's just a C++ abstract class that has all the virtual method that you need to implement to be able to create the library. And right now we support ROS to Humble here. And if you want to run the vehicle gateway Betafligth, you require pluginlib, which is the library in ROS2 that allows to create these plugins. Then the RCLCPP, because we are going to create some ROS2 topics and services to interact with Betafligth. And there we're going to use the common messages such as sensor messages and STD messages to communicate with this ROS2 API that we're going to create too. And then we have the vehicle gateway PX4. Again, we need pluginlib and RCLCPP. The PX4 itself creates some topics that you can interact with, and they are using the PX4 messages and also include the TF2, which is for converting some quaternion from Euler to quaternion and so on, this kind of conversion. And finally, we have the SINO-C. We included this demo because the client that we work for to create this demo want to use Sino in some specific use case, but we realized that we cannot release a package these days with Sino because Sino is based on Rust, and there is right now no way to release a package with Rust. So we are working on a PR to remove this dependency and be able to release the package in ROS distro. So this is how the API look like. So as this is a pluginlib plugin, so we need to create a class loader, and then we need to create a set pointer. With the loader, we instantiate our class, and here is when the plugin is loaded, and then we can use the class as another class you can use in C++. So we can initialize the gateway, we can arm, take off, do some stuff. We're going to see all the methods that we have to control the drone. Then we can land and destroy the gateway. And here are the methods that we can use with this API. So we can arm, disarm. We also have some synchronized methods. So this means that if you call the arm sync method, the API is going to block until the vehicle is armed. And if it's never armed, the code is going to be blocked for now. So maybe we can extend this API with some attempts or time or some of the things that make this method less aggressive. And again, we try to hide the complexity because, I mean, all autopilots more or less have the same functionalities, but they do things internally very differently. And yeah, so the goal here is to arm and hide everything, the complexity. The same with disarm and the same with the following methods that we're going to see. In general, all these flight controllers have different flight modes, such as, I don't know, stabilize, hover, mission, and so on. So we can get this flight mode with this method. We have some enums which try to define more or less all the method that all the autopilot has. What else? So we have the vehicle gateway type. So in general, we can use this API for multicopter, fixed wing plane, and VTOLs for now, but probably it's very easily to extend this for rovers, and maybe it could like be used by rovers and other kind of vehicles as it is. I didn't try, but I mean, should be feasible. And the same for VTOLs. So VTOLs have different states. So you can have the multicopter state or the fixed wing plane mode. So you can get the state in case this is a VTOL, and you can take off and land. And specifically for VTOLs, we have some specific modes to transition from multicopter to fixed wing plane. and also from fixed-wing plane to multicopter. And we also have this synchronized method that is going to block the code until we reach the desired transition. And we have other methods to get some information about the vehicle, such as the ground speed, the airspeed sensor, the altitude of the drone, the latitude and longitude, and we also have the get local position, which is some kind of you have the home position and distance from this point in meters. What else? So we can go to a location in terms of latitude, longitude, and altitude. We also have the same version for synchronize, but I mean, in this case, we need to set a threshold just to tell the method when it has to finish. We can go to a specific SYZ geo position, and if we are in off-board mode, we can also use a similar method, and you also can define the airspeed, which is the velocity of the drone, and so on. So yeah. So this is the C++ API. So what about the Python API? The only require for this library is Python 11. So we are creating some wrappers for this. And this code, this package that is called Vehicle Gateway Python, include all the wrappers that we can use to use this Python API. And you have there many different demos. You have some transition with VTOL from multicopter to fixed wing to multicopter to fixed wing to off-board mode, position control, velocity control, body rates, and position control. And if you want to start testing this, probably the first one that you want to test is the takeoff and land, which is going to arm, takeoff, hover, disarm, and land and disarm the vehicle. And this is how the Python API looks like. It's very similar to the other one, but I mean, here we also hide the complexity of the plugin lib. So we just call the init methods and you decide which plugin tab you're going to use. In this case, we want to use the PX4, but if you want to use Betafligh, you have to substitute there the Betafligh. And again, the signature of the methods are the same. We have RC, takeoff, get local position, and so on. But I mean, it's exactly the same API for both. I think almost the 99% of the API is covered with Python. I think there is a method or two which are a little bit different, but I mean, it's pretty much the same thing. And finally, we have the end-to-end testing and some simulation performance test. All right, so let's talk a little bit about simulation. So which are the requirements for the simulation? So this package right now is support ROS2 Humble, Gazebo Garden, and ROS GC. ROS GC is used to launch the simulations and also to generate some bridges between Gazebo and ROS2. And for PX4, we have the PX4 sim package, and this package will download and install the target that we need to run PX4, and also include two launch files, one to launch a single vehicle, which is going to launch Gazebo with a vehicle and all the things that are required. And if you want to launch another vehicle in the same world, you have to use the same script. And we also have support for multi-vehicle. So instead of launching several times the same script, we have a YAML file that we're going to talk a little bit later, and then you will open a wall with many vehicles all around. And the same for Betafligh. We have the Betafligh sim package, and it has two different launch files. One is to run a single vehicle, and the other one is to run a single vehicle with joystick, and which means that you can control the drone instead with a program, just with the joystick. And this pack, we include also the Betafligh Gazebo plugin. So there was initial work in Gazebo 8, I believe, for the Betafligh. So I just used a similar code, and I adapted the APIs to Gazebo Garden. The goal of this package is to create a UDP connection between Betafligh and the code. So the Betafligh CTL is going to receive the RC commands, and as an output, we will get the motor speed. And yeah, so we are able to simulate and fly the drone in Gazebo. in the launch file that I mentioned before, there are some relevant parameters that I want to mention. The first one is the drone ID. So as we support multi-vehicle, we need to have a way to identify which vehicle is each one. Then we have different drone types. So with the same launch file, we can launch different kind of vehicles. The DDS domain. So in general, DDS has some problems when there are many robots in the same domain ID. So we were testing also things with different DDS domain, and this is the way to change it. Some of the drones that we can include also some cameras attached to the models, and I'm going to talk a little bit later about how to configure this. Then we have the frame name. In the SDF of the world, we can include some frame tags that allow us to put the robot in a specific place instead of using numbers, using just a keyword. The same for the ground control, so we can start or not the ground control. Sometimes it's useful to debug something when you are developing things. Then the word name, and finally the model pose, which is expressed in XYZ roll pitch yaw. And the vehicle gateway models include some models that we can use to configure the sensor config parameter. And we have the word stock. Stock means that the model is plain, so no cameras, no sensor, nothing. And then we have the camera model, which includes the drone plus the camera attached. And if you want to create another version of your drone, you can include this very easily with this. So let's talk a little bit how Gazebo launch things. So we have the ROS2 launch file. We launch the PX4. We launch Gazebo, and then we spawn the model, and the model is spawned using a SDF or a URDF file. Gazebo is going to load all the plugins that we need, and then the simulation is running. So PX4 create an XRCE DDS connection thanks to the ROS agent. We can speak DDS, and with Gazebo and the bridges, we can communicate with Gazebo to simulate the drone. And this is all the topics that PX4 are using. And we are hiding the complexity of using this topic, but I mean, you should be able to access this. But I mean, if you are using the API plus the ROS topic at the same time, probably you will have some issues. If you are only reading information from the topics, I think everything should be fine. But if you are commanding things in the API and commanding things to the ROS2 API, probably you may have some issues. The idea is similar for the Betaflight simulation. So we have Betaflight, we have this UDP connection to send the RC commands and modify the values inside the controller, and then we will get the motor output. The Betaflight Gazebo plugin is going to be in charge of reading this information, and Gazebo is going to simulate this. And when we run the Gazebo Betaflight API, this will generate some topics, and we can use this information to use in our scripts or in our programs. Here is a demo with Betaflight. So we are simulating a drone, and the goal of this demo is to show that we can control the altitude of the drone. I think it's set to 4 meters. And the idea here is just to fly the drone using this API and to control the altitude. But I mean, Betaflight doesn't allow to use very complex mode. It's just all about rates and motor thrust and so on. So that's why we are using this dummy demo. But I mean, probably this API in the case of Betaflight is more for low control. And here we have the PX4 API working, and we have a VTOL with takeoff in multicopter, hover in multicopter, then transition to fixed wing, loiter a little bit in fixed wing, and the mission will start. We will fly to the north, we will change the speed, we will fly to the south, and then we come back home. We fly a little bit in loiter mode in the path to take off. We transition to multicopter, we hover again over the path, and finally we land. We have the same kind of demo for body rates and thrust control. So the demo is pretty similar, but using different API. What else? Testing. So here, the idea of this was to try to test this API with different autopilots. So the API is one, and we need to assure that all autopilots, let's say, we can rely on the API. So if we arm a vehicle, we want to arm the vehicle and be sure that the vehicle is armed. The same with disarm, take off, and go to any other place. So that's why here is important end-to-end testing, because we are not testing the autopilot, we are testing that when we are using the autopilot through the API, is working as we expect. We can run the simulation in headlet mode, or so in the GUI. By default is using headlet mode, because the goal here is to run this in CI. But I mean, if you want to use this with the GUI and try to debug something, you can do it very easily exporting this variable. We have some scripts here, very easy, so very simple ones. So the first one is arm and disarm, which says that all vehicles are arming and disarming. And then we have the takeoff and land. So we are going to check arm, takeoff, hover, land, and disarm. And we are using the launch testing ROS framework to do so. And we can do two things, more or less. We can do more, but I mean, we are using here two things. One is assert wait for, will allow us to check for outputs in the terminal. So PX4, when everything is ready and it was initialized properly, there is a trace called ready for takeoff. So if this trace is in the terminal, then we can continue with the test. And finally, when we are running all the scripts that we want to check that the exit code is 0 and there is no errors. And if everything is fine, so the demo should be fine. Here is the launch testing. So we have the ROS test launch file. So here the configuration is pretty similar to the launch file, but I mean, we put on top of this launch testing. So we launch the simulation that we have done before for a simulation. And finally, the only thing that is different is that we're going to run a script that is going to wait for the outputs. We're going to wait for the exit code. And finally, we are going to kill everything. This is important because sometimes some of the PX4 or Gazebo or maybe your script sometimes is hanging there and it's not dying. So we are assuring that everything is killed. And based on this end-to-end testing, we created some performance tests. So the idea here is that not all machines have the same resources. So we created this just to check how many robots you can run in your computer without not losing a lot of performance. So we collect the CPU and memory system usage. We also collect the Gazebo real-time factor, and we run the multi-drone simulation using the same domain and different DDS domain. And we are doing so because of the reason that I mentioned before, which is DDS. When you're using the same domain idea and you have many vehicles, you will have some issues with the discovery and the traffic is crazy. So we are trying to check also if this is affecting or not the simulation and the drone behaviors. So here is some graph that we can show. So the first one is the CPU percentage usage. And as you see, when you're using more drone, the CPU usage is higher. And the real-time factor in Gazebo is the same. With one vehicle, the real-time factor is 1. With 9 vehicles is 0.9. With 19 vehicles is 0.5. And with 13 vehicles is 0.2. I didn't try to use this with different physics parameter in Gazebo. I mean, you should be able to increase the performance if you modify the physics parameters. So let's talk a little bit about the multi-robot configuration. So right now we are only supporting multi-robot for PX4. In Betafligth, Betafligth uses ports, so it should be really easy to extend this to support multi-robot. I mean, I didn't do it because we didn't use it, but if someone is interested, it should be very straightforward. So we support quads or, well, multicopters, fixed-wing plane and VTOL. So here the goal is to spawn robots and generate namespaced topics and services. So we want, the same topics, but we want to identify which one is for each one of the drones. And we created a YAML file to configure the simulation. One is the vehicle ID, which is used for this multi-robot namespace thing. Then we have the frame name ID, the vehicle tag are the same parameters that we define in the launch files. So at the end, it's the same thing. And to launch this, we need to export an environment variable, and then we launch the PX4 sim multi launch file.py, and you should be able to generate your world with all the drones spawned in the right positions. Finally, the demo world. So this demo includes several helipads and one runaway that could be really easily extended with different configuration. The latitude and longitude are 0, 0. This is to avoid confidential data. So if you want to fly your drone for a client, you can start, working here, and then you can move to another one. But I mean, we don't want you to share this information. We include some material and some wave effect shaders. So what next? So there is sand and floor for rovers. There is water for boats. So yeah, so the floor is open for contribution and for people to try and test this. And at the bottom, you can see how you can launch this wall. And here is a demo. So we spawn 3 VTOLs, and we are launching 3 different scripts in Python that they are gonna take off and land the vehicle on this arm. So it's, again, very easy demo, but show the potential of the robot and how easy it is to configure a multi-robot setup here. And finally, the Sino demo. So we thought the architecture to use this API with the Sino demo. So we have different drones running together, and each one of them are living in their own ROS domain ID. And this is, again, for the multicasting issue with the discovery. And the autopilot may have an antenna using radio frequency or whatever other protocol to communicate with the ground station. But then, which is here, let's say, relevant, we are not using ROS2 to communicate between each one of the drones. We are using Sino to communicate between them. The reason behind this is because Sino is lightweight. So yeah, we just use this to simplify things. We are using the telemetry at 2 Hertz, and the data which are encoded here is vehicle ID, position, airspeed, and heading. And this is very easily to extend. If we think about C++, it's just to extend a map, a STD map in C++, so it's very easily to extend. Which is important is not to share a lot of information, because then we are going to have a very big package and probably the communication is not going to be very good. So Sino is good sending small packages. And one of the other cool things is Sino keys. So in ROS2, we are using topics, but this topic, if you want to subscribe to 10 topics, you need to generate 10 subscribers. But Sino is different. You can use wildcards. So you have a topic called vehicle gateway, the vehicle ID / state, and you want to subscribe to all the state topics, then you can substitute the vehicle ID with an asterisk, and then you will subscribe to all of them. And I think this is really, really, really cool. And if you want to read more details about the demo, please go and read the README. So finally, the demo here. Boom. So we have the first drone, which is taking off. This one is gonna do the mission, and the second one is gonna subscribe to this Sino topic, and it's gonna follow the other one. In both cases, we're using 2 different scripts. One to do the mission, and the other one is gonna subscribe to this Sino topic, and it's gonna follow the first drone and its position. So the first one, the one that is doing the mission, is the red one, and the light red drone is the one which is following the other one. We are using the airspeed to try to follow the other one with the same speed. And you can see when the first vehicle is turning, the other one is also turning. And this is really cool because you can connect to many drones. You can create formation or whatever, for some robotic, I think this feature is really cool. All right. All right, so conclusions. So the status is we support multicopters, fixed-wing planes, and VTOLs. We support also multi-robot and end-to-end testing in CI. So yeah, if you are probably doing something for one of your clients and you want to test this in CI and check that everything is working fine, this is a very nice place to check this if you are using Gazebo for sure. Then we can add support for other autopilot or tools. So there is autopilot is CleanFlight. We also have MapROS and other tools out there that can be included here, and we can hide the complexity of all of these things. And finally, we invite everyone to try and test it. So, and we are happy to receive your feedback and contributions. And finally, I want to say thank you to TII, which is the Technology Innovation Institute in Abu Dhabi, who has funded this project during the last year or so, something like this. So thank you for listening.
All right, thank you, Alejandro. That was a very nice presentation. Does anybody have any questions so far? You can also use the chat if you like. Anybody? Nobody?
There was a lot discussed today.
Yeah, I wanna ask you, Ramon. So the other day you sent me a link about this new ROS in PX4. The PR was created in the 6th of December last year, and the last time that someone worked here probably was 2 months ago. Do you know when this is gonna be pushed?
As soon as we get the 1.14 release, we're going to be merging this new interface, and we're also working on a control API so that we can offload all of the control to ROSland. We're trying to make sure that we build stable interfaces. So that's why I was interested in your work, because it's basically just another try at making a stable interface. Yeah, I have a lot of questions, but I don't know if any other one have any questions, because I want to make sure we give time to everyone.
Yeah. Make sure to get your question in before Ramon does his thing.
What about Braden? Braden, you have any questions?
My question is more about ROS GZ and the ROS bridge.
Mm-hmm.
When I've been using it, all of it works great, all the plugins, except for there's a to-do note in there saying that whatever update they did breaks the point cloud bridge. And so you can't bridge things with point clouds. Have you run into that? I found it very recently and haven't found much about this problem.
Yeah, I didn't try that much the point cloud bridge, but I mean, yeah, if you are finding some issues there, please open an issue, because I am the maintainer, so I can spend some time on it.
Okay, I think I will. Thank you.
Yeah, right now we are also working on the point cloud transport. I don't know if you are familiar with image transport. So it's gonna, let's say, allow us to not send a raw image. We can use some kind of compress point cloud through the network. So maybe this feature can improve the performance. I don't know, because we are having a lot of issues with ROS2 and point clouds.
What kind of issues?
Yeah, in terms of performance. So I mean, point clouds are very big, and DDS, you need to configure DDS specifically to send point clouds. So I know there is some work that Chris said started, but I don't know if this is already merged or not.
Gotcha. Thank you.
I guess perhaps like maybe not necessarily a question, but a discussion in the hope for my better understanding. So I'm just going to be honest. Like, I have heard of Zeno a couple of times, but I'm not super familiar of like what the actual thing is. I guess like it's kind of like a alternative to DDS middleware, I'm assuming. And as you said already a little bit before, is that like in terms it's much more lightweight as well? Like in what sense is it more lightweight than DDS that ROS2 is using?
Well, in general, it's used. I mean, I didn't use a lot Sino, but I mean, you instead of defining the package, you can use JSON to send through the network. So the package could be modified or is more extensible than ROS2. And in general, when you use it, they recommend you not to use a very big messages. So because it's for low latency and high throughput. So that's why. Right now, again, I mean, we have been using ROS2 DDS for a while, and we found some issues. But I mean, again, this is not a silver bullet, so we cannot, for example, for point clouds that Brandon mentioned, this is not useful. It's useful for sending these small packages and using also the wildcard. So it has some new cool things, but I mean, not all of them match with ROS2. I know that some people are trying to generate RNW for C. But I mean, it's not that easy because I mean, it's based on Rust. The way that Rust is released, we cannot release packages on ROS distro right now. So yeah. So I think that the Sino thing is something that we need to use it, but I mean, use it carefully because I mean, it's not, again, the way that the data release thing with ROS2 is not matching very well. So I don't know if we will see this soon in the ROS community.
Yeah, it's because it sounds indeed interesting for like the quick communication low latency networks between swarms. And two weeks ago we actually had a developer meeting talking about swarms. I don't know if anybody really mentioned Sino then. I don't think so. It was mostly in discussion about hardware at that point.
Yeah, right.
Yeah.
I don't think anyone mentioned the networking aspect of
No,
the setup. Yep.
Yeah, so it was very tailored towards hardware, and I kind of wanted to put some kind of like swarming autonomy in there. It but it really depends on the crowd. But yeah, it's an interesting thing because I would say that at least for I'm helping out with the maintaining of a package called Crazy Swarm 2, and that's definitely like something that we're kind of hitting against. Is like this fast communication possibility. Yeah. So I should probably start looking into it a little bit more closely. And the Rust. So I started to learn Rust a while ago. It's maybe a good reason for me to pick it up again and really do something with it. But yeah. But thanks for your explanation. But Ramon, perhaps you should just go ahead with your questions.
Yeah. All right. So I find your work very interesting because it touches on a lot of things that I have been very interested in the last few months. The first one is the how do you like launch pipeline, like all of the work that goes into launching PX4 or any flight controller and then having your package and simulation. That's something that we have right now, and a lot of other flight stacks have it, but it's not standardized and it's a pain to maintain. In PX4, personally, we're trying to move more to a Qualcomm build setup so that it's similar to what's happening already within ROS, and it's the same developer experience. We're still struggling in how to do that. So that's why we like seeing use cases of other people implementing it, because we're not ROS developers by nature. So first of all, thank you for doing that. But how can we improve our own build system to match more of the ROS type of doing it, the way of doing it for ROS developers?
Well, in general, I think I already mentioned this the other day to you. I mean, the first thing is documentation. So right now, I think the new simulation environment with Gazebo, with the new Gazebo, is not very well documented. So we struggle a little bit with all the launch file and scripts that you have to run all of this. And you have to, dig inside the script and check what is already done there. And the other one, probably, yeah.
Hey, don't hold back.
Yeah, I would say that that in general having someone in the PX4 community that have some ROS expertise could help. Because I mean, right now I cannot tell you again what is the keys or which are the solutions for this. But I mean, having a easiest way to launch PS4. I didn't say that we are hacking how we launch PS4, but I mean, it's not very well explained how it's launched. So in general, when you want to launch ROS2 for an external project, you want to use the executable, and that's all. And you want to, let's say, launch the command and you forget about it. But I mean, PX4 is not that easy. You need to create a temporary file. You need to set a lot of environment variables, which you don't know why you should do it, and so on. So yeah, so the first thing is documentation, and the other one is try to simplify and understand that people want to run just the command with some probably arguments, and that's all.
Awesome. That's great feedback. Thank you.
We have a question, if we can ask that in between your questions, Ramon.
Yeah.
So from Arsh, we have, thank you for your presentation, Alejandro. I'm currently in the process of creating simulation with different types of robots that I can use for teaching purposes, and this will help me for sure. Oh, yeah, it's not a question. It's a thank you. You're being thanked.
You're welcome.
I guess he's already gone, but then just go ahead with your next question, Ramon.
All right. So that's on launch files and all that, but what about the API? So you're taking all of the DDS, the UART messages that we're exposing through DDS. Have you found those are sufficient, or is there anything else that you'd like to see? And
yeah, I mean, it's again, I mean, the first thing that I want to tell you is again documentation. So right now, for example, we're gonna use, for example, the off-board mode. You need to send at least 7 or 8 times that you want to change to off-board mode, and we don't know why we need to do this. But even in the official packages, you have to do it. But there is no, let's say, documentation about why we have to do it and why that. And you have to do it in a particular order. You have to arm and then go to off-board mode. And the API, I think, is sufficient because we can do very cool stuff. I mean, it's how things are documented. The one that I always complain.
Mm-hmm. All right. Yeah. I think we want to get
and
people out.
And I can find all the sample you want, and I can also the other guys that contribute in the library. But I mean, again, it's just how we can use PX4, which you can do a lot of things, but I mean, sometimes it's not very well defined or documented how you can do it.
Definitely.
And that's why the client that we have, they want to do this because, I mean, they have to do many tricky things, and they told us, okay, do the tricky things by yourself and hide all the complexity because we just want to use PX4 and run our code. So, honestly, just worry about, let's say, high-level code, not low-level code.
Yeah, and then that's what we want developers to be focused on. We want that type of developer to be welcome on our community too. One question that is not PX4 specific, it's more on the nature of the project. Do you see any benefit of having a standardized API between flight controllers?
Yes.
I mean, and why? And I guess the context of my question is because I was a strong believer of this until recently, where I actually realized that the way the autopilots behave and how they expose their interfaces, it's actually the way it works for some developers, and that would be the way for one developer to pick one over the other, right? And it becomes a differentiating factor when choosing a stack. So, what's your thoughts on this?
Yeah, I mean, I am also a truly, like to say, lover of standardization. So we tried to do this a long time ago in early Accutronic. We tried to standardize many kind of messages and these kind of things because at that time we were using 2 or 3 different autopilots in our technology. And again, we need to build 3 different APIs or 3 different programs or applications to run the same kind of things in the same place. So something that I was missing is that, okay, why I have to do this, 3 times if I can do it only once? And that's why. But I mean, I understand that all the projects are open source, and all this project has its own kind of interest, and it's very difficult to, let's say, try to unify this kind of thing, because all of them have small things that you don't want to, or you want to expose, but probably this API is not able to expose, or these common interfaces are not going to expose. So how do you deal with these small and differentiate features that you have in your autopilot, and you cannot do it in the standard way? So that's the only thing that I see, that this is very difficult. And in ROS, again, if you change a parameter in a message, then you are breaking ABI or APIs and so on, and it's not really easy to do it in ROS. So if you want to standardize, you probably need to understand that you're going to lose some features with this API, but at least many people can use it easily. So there is a
trade-off there.
A trade-off, yeah.
Yeah. We went through this exercise. Well, we were part of this exercise already with MapLink interface and how different autopilots implement some messages. And if you try to be very specific about how a sub-protocol should work, or like if the flight mode should work, then you, at the end of the day, you're forcing the flight controller to be the same way or behave the same way, which at some point might not be to the best interest of those projects. But at some point, the benefit is so clear that, like, having developers go through the base experience and they know how things work. So I think there's a balance, like you're saying there. There's a trade-off to be made, and there's a balance on what to expose which way. But we're really interested in pursuing this and seeing how can we standardize this interface.
Sorry.
But at the end, okay.
Yeah. Just to say, like, there's a little eye on the time. Maybe perhaps kind of round up your question and see if anybody else wants to ask a question, because then we also have to select the topic for the next meeting and to have like a couple of announcements. So just saying. So please finish what you want to say.
I forget it.
Sorry. I knew the risk, but I know that first it's like Ramon usually has to go.
No, thank you, because I was not paying attention to the time.
No, what I want to say, is that so this common API is really cool. But I mean, if you are also an open source project, so you have to make money in some ways. So probably if you expose everything in these APIs, you don't have this differentiation from the other ones, and this is how probably you will make money. So you will probably get some users, or because you are using this API, but then you have to have some clients that want this, this step more. And this is something that probably this API is not really well do it for that. I don't know if I explained myself very well, but I mean, at the end, this open source project need to make money, and these things that you cannot standardize is because you are different from other things, which are also cool. So again, trade-offs, and yeah.
I guess also I think also like Betaflight and PX4 and Autopilot are kind of like different. Yeah, so it's actually one of the topics that we're soon going to select for the next meeting. So if more people are interested to talk about message standards for UAVs, then perhaps you should choose that one. I think it's like if anybody else would like to ask a quick question, now is the time. Before I take over the presentation again. So nobody's asking? Okay, then I'm just going to move on to share my screen again. Right, ta-da. So as you can see, we have a whole bunch of topics, and we've already discussed quite a few of them, but not all of them. So I've created a poll again. So let me launch that poll. And I think, you're able to select a poll if you go to the right side, bottom right. You have like a square, a circle, and a triangle, and then you can select polls there, and then you can vote for which topic you would like to have the ROS Aerial Community Workgroup meeting for mid-August to be about. Is anybody seeing the poll at this moment? Are you able to find the poll?
Yes.
Awesome. All right. I see the votes coming in.
Hey, Kim, quick idea. Let's run the poll here, and then let's post the results on the forums and make another post there.
Yeah, that's always what I do anyway. So that's
awesome.
So I'm just going to like, we have 5 votes at the moment. Can we place a vote? Do we have a vote? No, I would actually like to hear what you guys want to. I want to talk about anything. So.
All right. I need to leave, but thank
Yeah.
you, Alejandro. Thank you, Kim. Thank you, everyone. And I'll see you in the PX4 Q&A if we have the time. If not, then I'll see you mid-August in the next work group meeting. Goodbye.
Bye.
Happy summer.
Everyone.
All right. So there are 6 votes, and we're with 8 of us. So okay, I think it's probably going to be good as long as everything is fine. So let me just end the poll right here, and we have a tie. Oh no, what to do? We never had a tie before, so it's bound to happen. So there's planning in 3D has 2 votes, and message standards for UAVs. So I think actually based on the last discussion also with Ramon, it might be actually nice to talk about message standards first, and then we can save planning in 3D for the one afterwards, just to make it fair. Then we're not going to do the poll again. Then it's just going to be planning in 3D. If people are okay with that. Right. Ryan?
Yeah, sounds good. Also, Steve from NAB2's out of town for a while, so it'd be good to wait to do that talk until later when he's back in town.
All right. Yeah, then we can invite him to our group as well, and probably like and then it's going to be for the one in September, so that's going to be in a time when more people are back and things like that. But okay, but then in mid-August we're going to talk about message standards in UAVs. Perfect. So the next meeting, that's going to be a short summer break for a month. So the next 2 meetings are cancelled, also already on the calendar. So we are going to have the next meeting is going to be on the 16th of August on a Wednesday, again, 2 p.m. Universal Coordinated Time. And then we're going to discuss about message standards for UAVs. And of course, like, this is the GitHub organization for the working group with the aerial robotic landscape. To add yourself as a member for anybody that's new over here. And if you want to do a presentation about your project too, yeah, send me a mail, Kimberly, or Ramon an email, so you can find that right here. And yeah, that is all for so far. So I would like to wish you guys a nice summer break. And I'm going, yeah, we'll see each other again in August.